Maybe the rhino needs to pet the dog downstairs.
The rhino would crush it.
Not bear.
I don't think that would go very well.
Yeah.
Somebody's gonna lose in that one. Hey, we get to talk about triangles today. Yeehaw! You know what the first question I'm gonna ask you is, don't you?
What's a
What's a
triangle?
triangle?
A shape with 3 sides.
What is a triangle? Here's some examples for you. I got a purple one, I got a red one, and I got a green one. You want to give this a shot?
A triangle is a shape that has 3 sides that connect together at 3 separate points.
That might be the worst thing.
And they can either all be the same length, or all be different lengths, or like some will be different.
Not horrible, but a couple things. First of all, since we've talked about the logic unit already, our definition should be written in if-then form, so then we can talk about the reversibility of it. So, say that again, but put it in if-then form.
If a shape has 3 sides,
No, start with a triangle.
if a shape is a triangle, it
Bingo.
has 3 sides.
Then,
Then it has 3 sides.
that's it.
Yeah.
If a shape is a triangle, then it has 3 sides. That's your definition?
Sure.
Draw a triangle then.
1, 2, 3. Is that a triangle?
Okay, if a shape is a triangle, then it has 3 sides that connect together at 3 separate points, and they have to be enclosed.
1, 2, 3.
At the front, they cannot. If a shape is a triangle, it has 3 sides that connect at 3 points, and they do not intersect.
Oh, I know it.
I know what it is. I just help.
Do these 2 segments intersect?
Yeah.
You're so close. You want to go once more before I ask somebody else to help?
Oh, was it mine too?
No.
No?
Almost the same.
Rebecca? Emmett, did you think to throw your arm in front of her when all of a sudden I would like get distracted and call on you?
Okay, so if a shape is a triangle, then it is a geometric shape with 3 sides.
Is this not a geometric shape?
Excuse
No,
me.
It's not? So,
Because it's open.
well, we said we haven't defined geometric shape.
Oh.
You want to use your one time?
I thought you wasn't allowed to.
One time per day?
Yeah.
Deb, go.
No, I want.
You think?
Oh.
Come on.
Okay, so if a shape is a triangle, then it has 3 sides that all connect at an end point.
No. Come on.
Almost perfect.
Hey.
Connect at the endpoints. We don't want only one endpoint, we want the endpoints. The triangle is 3 that connect at the endpoint. That's good. That works. Say that again.
What did I say?
If a shape is a triangle,
If a shape is a triangle,
then
it has 3 sides that connect at the end points.
beautiful. I don't really have a counterexample for that, so we'll go with it as the definition then. That sounds great. There are other things that become inherent with that definition. It has an inside and an outside, the things that we dealt with when we talked about polygons. Now, another alternative definition is you could have gone with the polygon approach and said a triangle is a 3-sided polygon, but that works just fine. Question?
Could you repeat the definition just one more time?
Sure. Deb, could you repeat the definition one more time? It's exhausting, isn't it? Welcome to my world.
Okay, if a shape is a triangle, then it has 3 sides that connect at the end points.
Excellent.
Yeah.
Total anarchy going on next door. We're going to classify the triangles 2 different ways. First time by sides, and then the second way by the angles. What are the different types of triangles according to the sides? Anybody have an idea? Vanessa.
Scalene.
Oh, I hate that
Scalene. What's a scalene triangle?
A scalene isn't scaling when one side's longer and the 2 are, or they're all different.
You asking me or telling me?
I don't know what a scalene is.
They're all different. All different. All
Because I
the
would-
all the all the lengths,
No,
all the
it's
side lengths are
like, no,
different.
it's-
All the side lengths are different.
And angle.
No.
By size.
That's called, it starts with a P, I think.
So side lengths are different.
Okay. I'm afraid to click because I don't remember what order I put them in, and I don't want to give away the other answers. Anna Maria, what do you got?
Like for
Other types? Yeah.
an equilateral triangle.
I was.
Okay. Equa means,
Equal.
and lateral means
Size.
sides, so it has 3 equal sides. Okay. Michael?
Isosceles.
Yeah.
Oh my.
Isosceles, which means what?
That's when two sides are equal. and
Only
the other
2
is
sides.
Yeah.
not. Two sides are equal and the other is not.
The other is not.
Yes.
So an equilateral triangle is not isosceles?
True.
Sure.
No. No.
Yeah.
Wait,
because
equilateral
lateral
is
has all
two.
the-
Nice.
So you're going with exactly 2 sides, not 2 or more sides.
Well, because if it
Exactly
was
two
more
sides.
than.
Exactly 2 sides.
Yes.
Okay, let's see what I put up here. Equilateral, it's a good thing I didn't click. All 3 sides are congruent. Isosceles, we're gonna go with at least. There's a reason for that, which we'll get to later.
Okay.
We've talked about this before, but remember the whole dog golden retriever thing, right?
Yeah.
Yeah.
All golden retrievers are dogs, but not all dogs are golden retrievers. The same thing is true between these. All equilateral triangles are also isosceles, but not all isosceles are equilateral.
What do you say isosceles?
Isosceles.
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 Look how it's spelled. Isosceles.
Well, we put silent.
According to our definition, an equilateral is also isosceles.
Why?
But an isosceles doesn't have to be equilateral. This triangle, for instance, is not an equilateral triangle because we only know the 2 sides. And then the last one, as she said, is scalene. No congruent sides. Or as you said, the 3 sides, none of them are equal, same thing. Hot diggity. We good? How about now?
Yes.
Who's missing today?
Molly.
Don't they?
I don't know.
Okay.
I don't know. Yes.
She's at Kempo?
Ah.
Just guess.
Oh, okay. How about by angles? No, we've heard enough out of you 2 chuckleheads. Let's get somebody else. Ashley,
No one's gonna raise their hand.
any ideas?
Can we like video?
Yeah, I know.
Punch us.
Right triangle, very good. Any others? Wait, what's a right triangle, by the way?
Triangle has a
90 degree? Can it have more than one? Yeah, okay, good. What else? By the way, it can't, only one. I understand.
All sides are.
Cute, like it's pretty. Oh, cute, like, okay, what's a cute triangle?
the angle heights are below 90 degrees.
All of them?
Yes.
Okay. Third?
Obtuse.
Obtuse.
Yeah.
Huh?
Obtuse
Yeah.
triangle.
What's an obtuse triangle?
All the angles are over 90.
All the angles are over 90? You sure?
No.
2 or more.
They don't like that.
That is
2 or more?
Good job, Ashley.
Don't listen to them, he has no idea what he's talking about.
One.
Just one. Acute triangle, all 3 of the angles are acute. Gesundheit. Equiangular, equa meaning equal, angular meaning
I was gonna say.
angular. Gesundheit.
Bless you.
And the other 2 you gave me were, and? I don't remember what order they're in, so I'm afraid to click.
I would give
you gave me 4. You didn't give me this one. I gave you that one.
Right.
Good. Right. One right angle, can't have 2. We'll talk about why later. Can't have 3 either.
That wouldn't be possible.
And then obtuse. Only one obtuse angle, can't have 2 or 3. We'll talk about that later. So we can now, since we've classified triangles by sides and by angles, we can combine them into all kinds of fun things. The important question, though, is which combinations don't work? So, in other words, I can have a right scalene triangle, correct? That's pretty much a right scalene triangle. That is not the same length as that. That's not the same length as that. That's not the same length as that.
I mean, it could be.
It could be, but,
You have to do that.
Theoretically.
right, but doesn't have to be. What combinations don't work? Michael?
Obtuse and equilateral.
Obtuse and equilateral. So you can't have an obtuse angle where, or obtuse triangle where these two are equal as well as that.
I believe so.
That is correct. Any other combinations that don't work? There are a whole bunch. Nicole?
Right angle and equilateral.
Equilateral and right angle, or right triangle do not work. Okay, so you see that there are some combinations that work and some that do not. So 2 of the triangles we're going to focus on today are isosceles and right. And so the isosceles, this is the stereotypical isosceles triangle. It has 2 equal sides. It could have 3. I'm just going to deal with the fact that it has only 2. The 2 sides that are equal are called the legs. Anybody else bothered by the cursor there in the center of the screen?
Yeah, a little bit.
That's driving me crazy. I'll hide it over there. What's the bottom called?
Base.
Base. It does not, however, have to be sitting on its base. If I tilt that triangle over, legs are still the legs and the base is still the base. People have a tendency to think whichever side is on the ground or downward has to be the base. What are the corners called?
Angles.
Points.
Points. What are those points called?
Vertices.
Points.
If I have one, it's called a
Vertex.
vertex. If I have more than one,
Vertices.
not verti. Vertices.
Vertexes.
Verti. It's only if it ends in US. Radius. Cactus.
Platypus.
Platypi. Gzi. School by.
What?
School by. Big yellow things you ride home. Are you questioning me? That's what I thought. I ride the school bus home. Look at all those school by. Then we have a right triangle. There she is. What's the long leg, or not leg, what's the long side called, Will? Don't believe the, no, LL Cool J song, don't believe the,
Oh, he's my favorite. I didn't know his songs though.
don't believe the,
He's-
you
That's
know?
actually a really good triangle.
Hypotenuse, don't believe the hype?
What?
No? You guys, do you even know who LL Cool J is?
Yeah.
Yeah. You know he used to be a rapper, right?
Yeah, he's in
NCIS.
Right, yeah, he, as I said, he used to be a rapper. Hey, Will, what are the other sides called?
I wish I was high.
Their legs, correct. So the congruent sides on the isosceles triangle are called legs, as are the non-hypotenuse side of the right triangle. But you knew that already, because we did Pythagorean theorem already. We talked about right triangles. We know how they work. We're experts in right triangles.
So is high.
Hey.
Save your hay.
You might be known,
Can you go back one, please? Okay. Thank you.
Sorry.
Oh.
Sorry. Go.
There is no escape.
Except if you
I
go
don't like
around.
How was I supposed to get out?
Find the perimeter of that triangle, please.
Challenge accepted.
I don't know how.
So jettison yourself over to that desk, and I'll pull that one out. There, you're good to go. Oh, she be comfortable. Hold that. Don't touch it. You're oldest. Don't touch it. I got it. I got it? All right, good. Here. This back. Could have done it without you.
Nobody knows.
Emmett, go.
Wow, what just happened?
For you?
Question?
May I go to the bathroom?
No.
Right now?
Whenever.
He
Okay,
needs
so no, later.
Okay, see you later.
Oh,
I'm not going anywhere. Jack, what'd you get for an answer?
31. What?
Can somebody
Wait, how?
confirm?
Nope.
Somebody get a different answer?
set this up.
How do you do it?
Anybody else?
Tell us the pointers.
What do you got? Is not an
for-
answer.
For X or for the? Oh, the.
No,
Never
because you have
mind.
to find X.
No, he's right.
Pascal.
He's right.
Talk us through it, Jack. Unless you want to come up and do it.
Yeah. Yeah.
You get to use the fancy pen.
This is not.
Hi, Mary.
Yeah, it's 31.
They want you to break dance while you're doing it.
No, I can go with this.
Give him a second. Let him finish the last.
Yeah. That's like the best handwriting.
I better.
I can read that.
Just ignore them. Keep going.
Sorry, Jack. Not bad.
We're all done. Let's give it up.
You good.
What would be your units here, Jack? Don't know, right. Since I didn't give you, you just use U for units.
31 years.
Built into the problem, there is a pretty much a checks and balances whether you realize it or not. So he set those two equal because they're marked equal and it's isosceles, and therefore solved x being 6. Plugged it back in. The checks and balances comes in right here. When he plugged the numbers in, those two sides turned out to have numerically equivalent answers or lengths. They should. If you do that and you plug it back in and your answers don't match, you did something wrong because it told you in the problem they have to be congruent. Okay. Thank you, Jack.
Where did you get this?
X
Oh.
7.
That's 7 right there?
Yeah.
Okay.
Plus C then.
It's a little hard to see, but there's an M right there. As you can see right there.
You didn't come.
By the way, it's equilateral. Can't work my own technology.
How was that?
There we go.
Yeah, wait, what?
So the question is, how do we know that triangle JKM is in fact equilateral?
It says it in the question.
Good answer. That'll get you far on the next quiz.
Ooh,
Go ahead.
can I do this one? Alright.
Sure.
So, the midpoint of JL, if
Mhm.
M is the midpoint of JL, then JM is 7, or 0.75. then ML is also 0.75. And then that tick marks on KM and ML, I mean they're equal, so that's also 0.75. And then all the sides are 0.75.
Good. Unneeded information. Okay. Now, ways that I could vary this problem would be to start over and give you the problem this way.
You kind of can still see it, but okay.
Now how would you solve it?
Pythagorean theorem.
Pythagorean.
Becca.
I would use the Pythagorean theorem to get the hypotenuse, and then divide it by 2 to get the midpoint.
Yeah, from that point, do the same thing that Paul did, right? So, again, you can't use that unless we know that that marking is there, so I would have to add that for that problem. Okie
Oh. Where's?
It's a little hard to see, I apologize,
See,
but there is a right angle down there in the corner.
my answer.
There is a problem with this example. What's the problem? I'm guessing some of you have an answer?
Yeah.
Yeah?
It's
In order to get that answer, you had to cheat. Why did you cheat? Or I should say, how did you cheat? Nessa?
You don't know if the angle C and angle T are the same.
Correct.
To set them equal to each other.
So you set them equal to each other.
No, I didn't.
You didn't. You wouldn't go down that dark path. Do you think others may have?
Yeah.
Okay. How did you solve it?
I didn't solve it.
You just stared at it?
Yeah.
What did you do?
You do 3x plus 7 plus, 3x plus 7 plus 7x plus 10 plus 90 equals 180.
Why is that cheating?
Because we're not supposed to know that yet.
Right, we don't know that yet. What is that you used?
90, no.
No? You know that's 90 degrees, we've covered that.
Oh, the all sides equal 180.
How about all the angles equal 180? Yeah. Do we know that yet? No?
Yes.
Guess what we're doing tomorrow?
That's what we're doing.
Tomorrow we'll be able to legitimately solve this problem because we will know that these three angles add up to 180. Wait, I'm not done yet.
What's our home?
He ain't done yet.
If we know that all three of these add up to 180, then what's the relationship between these two angles?
They add up to
Complementary.
They add up to 90, they're complementary. When you do that, yeah, complementary, you get that. Last thing, hold on. You have a distance formula on your calculator, which you can now use to easily find the distance and or the lengths of those three sides of the triangle. Once you know the 3 lengths, you can then classify the triangle by its sides. You can't necessarily classify it by angles yet, but we will get to that later. Notice you want to determine if it's a right triangle. So you find the 3 distances. You have no idea what the triangle looks like. How do you determine if it's a right triangle?
You plug in the points.
I'm sorry?
You plug in the points and then graph it.
No, doesn't even need to be graphed.
I'll use the Pythagorean theorem.
See if it satisfies the Pythagorean theorem. Have a good day, everybody. Day 1. I'll unlock it in a minute.